Can you, are we good?
Yeah.
Can you read this? I just want them to be able to see this. No, you don't have to do anything. I just want to know when you can read this number 5, example 5. Can you read the question?
Oh, no. No. Yes.
Right there?
Yeah. You
Yeah,
can
go forward.
Yeah, it's okay.
Good?
Yes.
I don't need the answer. I need them to be able to read the question.
Yeah, they can read.
Oh, I don't care. It's okay. But
Yeah,
I
we
just,
can
just the question.
Yeah, we can read it.
You read the question?
Wonder watched the fish in her fish tank and noticed that the angelfish like to feed at the water surface, while the catfish feed at 0.300 millimeter below at the bottom of the tank. If the average density of the water in the tank is 100 kilogram per meter square, what is the pressure of the catfish?
Okay, good. Now, that was Abdul. He's actually from Brooklyn, and he has a very heavy New York accent. And he was pretending to speak with, and yeah, don't lean on this. Don't lean on that, dude. And he was pretending to speak with a French accent. It's a pretty good French accent, don't you think? I thought it was pretty good. Okay, well done there, big guy. Okay, so let me read it again so I know what I'm doing. Wanda watches the fish in her fish tank and notices that the angelfish like to feed at the bottom, at the water surface, while the catfish feeds 0.3 meters below at the bottom of the tank. If the average density of water is 1,000 kilograms per cubic meter, what is the pressure on the catfish? Well, remember we said, this is huge, remember we said that DGH was okay for pressure. Because we know that pressure for middle school is force over area. And we said that pressure here, expressed like this, density, I'm not teaching chemistry, density rho, right, times G times H equals pressure. It's okay. Remember we said that? Okay. So this is the equation. This is the pressure of the water in the water tank. But the total pressure on the fish is going to be the atmospheric pressure plus that pressure, and that's pH. Now, pH, let me just read to you the former page. It says right in bold type print, the hydrostatic pressure, this is actually fluid statics, not dynamics. This is the hydrostatic pressure equals the atmospheric pressure plus what I call the local pressure, the fish tank, the water in the fish tank. Now remember, the water in the fish tank is simply a function of depth. Well, yes, it's a function of the density of water and the fact that you're on Earth, but it's the height. So in other words, the difference between the catfish and the angelfish is a matter of depth. That's all it is. Okay? Now, so let's do this. So this is 1,000 kilograms per cubic meter, right? Times 10 meters per second squared. You okay with that? Yes? Times the depth. Right? And that's going to equal, we're doing an example problem. It's okay. It's okay. It's okay. And then it doesn't give the specific local pressure, but that's okay. You can do it in your head, really. You could say this is 1,000 times 10 is 10,000. So 0.3 of 10,000, easy, right? Right? So, but then what you have to do is, you have to add on to it. So get out your calculator. You have a calculator? Go, this is the local, what I call the local pressure, okay? So my hydrostatic pressure is going to be 1.01 times 10 to the 5th pascals plus, what's this? What's 1,000 times 10, again, you can do it in your head, really, times 0.3. Can you do it? you're using a calculator. That's okay.
Oh, this.
Yeah. 1,000 times 10 times 0.3.
It's 100.
What is it? What is it? She doesn't trust herself. It's okay.
It's 3,000.
Yeah. Right. 10,000 times 0.3 is what? 300,000. 3,000?
Yes.
So you're going to say 10,000 times 0.3, right? Is what? What's 0.3 times 10,000? They don't believe the calculator. They don't believe it. Yeah, do it. What's 0.3 on your calculators? Do it. 0.3 times 10,000. What do you get? 3,000, of course. 3,000. Okay? So what is, so here you have 3,000, and we know that's pascals, because this is all SI units, right? Kilograms, meters cubed, seconds, squared, right? So it's good, right? We didn't break any rules. So pressure, the SI units for pressure are pascals. So what is 1.01 times 10 to the fifth plus 3,000? What do you get? Want me to read it?
104,000.
Yeah, that's right. So it's going to be equals 1.04 times 10 to the fifth pascals. Right? You get it? Easy? Go. You can turn it off.